First part of the session, I'll cover the theoretical aspects are more on the conceptual level, and then the second half I'll cover the demonstration part of it, and then we will be using some simple mobile app to view how the digital twin will work, and then I'll also requested my colleague Mr. Jeevan also to join today's demonstration. So he is the expert in development of the digital twin for the industrial equipments and other critical assets. So he'll also will be joining the second half, and probably during the demonstration session, we may have to install small app, maybe from your Android phone. If you're using, you can use Play Store and download application called Euphoria View. So anyway, it will not take much time, just less than a minute it will take to you to install, whether you are using Android or iPhone. So both versions are available, and then you can use during the demonstration. So this is on the overview about today's session. So those who of you missed yesterday, I'll just spend a couple of minutes on a recap of what we discussed yesterday, and then we will get into the today's session after 5-10 minutes. Yeah. So hope that helps. Right? So I'm sharing my screen. So hope you are able to see the slide deck. Yeah.
Yes, yes, the slide is clear. Yes,
Yeah.
sir.
Yeah, sure. So yesterday we gone through these 4 key topics. Why we have to know more or learn more about Internet of Things, and then what are the key applications, and then what is the key construct which defines the Internet of Things, and then few basic things, and then demonstration aspect of it. I'll just know the importance of the IoT because of the huge growth in the market, and then it's even it is touching every part of our life, whether it is our health aspect or other manufacturing or even day-to-day service industry. So every aspect of our life it is touched upon by Internet of Things, maybe in the direct way or indirect way. And these are the key applications. Even today's contract tracing and other industries, including the connected vehicles kind of environment, we still use IoT. And then some of the use cases which touched upon, which enables basically the individual people's life, like people with vision impairment or hearing impairment. So there are mobile up with Internet of Things, which enhances their life as well as others. And then it's the key aspect is it is Internet of Thing is created, the term coined by Kevin Aston. He was a consultant with PwC, and then these are the key drivers of Internet of Things. And then for the entire session or the entire workshop, we will be focusing on even though Internet of Things covers the 4 topics, but we will be discussing more on the industrial automation, or how the controlling aspects of the industries, how Internet of Things can help. And the second is home area networks, or simple use cases based on our automating or the building automation or the home automation kind of scenarios we will be discussing most often. And then the evolution of the IoT happened because of one basic thing is Cortex M0, the small miniature version of the microcontroller, and then the associated Bluetooth Low Energy Protocol, and then by iBeacon, and then later it is adopted by Apple Incorporation for their iPhone. So that set the trend, and then the form factor of the devices got reduced, and then even these are the key components of IoT. So sensors, actuators, which is how the transducer works in the industrial environment as well as even today. Only thing is it's all miniaturized now. So, and then how the network enablement happened. So, and the sensors, these are the 3 major types of sensors and the fundamental principles behind that. and then what are the other type of sensors which we can use for simple home automation kind of scenarios, and then the actuators, whether it is a digital or analog, controlling motors versus on off kind of switch enablement, and then how the data flow happens in the circuits, and then the fundamental aspect of the circuits, and then we got into the simple controller based on Arduino, and then the key components are the three key details about that, and then the what is the embedded program or the embedded systems we call, so that is custom built for the specific industrial or home automation kind of scenarios, and then the network gateways, how it is changed over a period of time, not only enabling our standard way of communicating a protocol from different devices to a centralized place, as well as now it is more advanced versions which includes edge computing, or it has a little bit of processing power inbuilt to host AI and machine learning models as well nowadays. And then we got into the demo of using some of the tools. So we got into the Arduino editor. So this is a web-based Arduino programming tool, Sketch. And then what are the key components of that, and then how to connect them, and then how to write a simple program. Some of the example program which is used to connect a physical board and then scene, and post which we seen a tool called Tinkercad, and then you can use it for emulate or simulate the Arduino board, and then how quickly we can build some use cases, the inbuilt code, and then you can start simulation and just to see some few sensors and actuators and other components in action, right? So this is the recap what we have covered yesterday, and then recording is already shared, so you can just spend some more time and then you can familiarize yourself, and then so now we'll get on to today's session. So yeah, yeah, today's session. So we will be covering as we discussed. So to the so one is Industry 4.0 and the second is Digital Twin. So just to have it.
ஆப்ஷன் வருது ரெண்டுலயே போட்டு கன்வெர்ட் பண்ணி MP4 போட்டு ரெடி பண்ணி வச்சிருக்கேன் ஷேர் மட்டும் பண்ணேன் டிரைவ்ல போட்டு வச்சிருக்கேன் நானும் போட்ட உடனே உங்களுக்கு இப்போ ஷேர் பண்ணேன்
So brief agenda for the today. So why we need to discuss about Industry 4.0, and second is application of Industry 4.0, and third is digital twin. Why we need to get into details, and then what key components of digital twin, and then few applications of digital twin. So these are the main agenda for today's discussion. And then before getting to Industry 4.0, so once we got the data using Internet of Things about various tools and other things, so now we have enough data, or more amount of data, quantity of data about the particular thing, or about the particular process, or particular manufacturing, or other particular business operations. So now we need to structure the data, because unless we structure this particular data and then create a rules around that and then have a standard framework around that, it is very difficult to consume the data and then make a meaningful insight out of the data. So that is the background. Industry 4.0 has been said. So it is a continuation of the continuous evolution of various transformation happen in the industry, especially the manufacturing industry, and then how it adapted to the current scenario of IoT and other related data standardization and frameworks around that, how we need to communicate with different components or different machineries and then different systems around that, because some of the systems were existing for years together, multiple decades, right? For like the process control systems which are there for many years. So it has to communicate as well as the legacy applications, as well as the even the today's the advanced microcontrollers, kind of our mobile applications as well, or mobile and other similar embedded systems. So that is the background of Industry 4.0. So on the digital twin, I'll just play a small video, so which will give how the Internet of Things so far we discussed yesterday, and how it can be leveraged to improve the performance, maintenance, and services aspect of an industry.
Sorry to interrupt, just one
Yeah,
minute.
yeah.
I request people to switch off the video, please. In case, if you are not formally ready to join the presentation, please switch off the video. If required, you can switch it on. Thank you. Yes, sir, please.
Yeah, so I'm just going to play a video, so which will explain about the
Infosys. What we have here is a 3D printed aircraft jet engine. It's an open source model that we've made a couple modifications to. This is an IoT use case for our artificial intelligence platform with large industrial assets. Myself and two other VR experts spent the last week and a half developing not just this model, but an entire augmented reality overlay that goes along with this experience. So with this 3D printed turbine, we have a couple sensors on board. There's a strain gauge sensor to measure the deflection of the plastic. There are temperature sensors to measure the temperature of the combustion chamber, where one of the two engines are lying. And those two engines on board, each of these two engines drive the separate spools on board this engine. So all of these sensors are collecting data, feeding this information up into the cloud, and then we're able to grab that information from the cloud with the Microsoft HoloLens and display that information on top of this jet engine turbine in a contextualized manner. The strain gauge will show a blue-green heat map overlying the deflection of the plastic throughout the casing of the engine. The temperature sensor will give the user a red-orange stratification of the temperature through the fan section up through the combustion chamber and then down into the turbine. And the user is also able to get information on speed throughout the different blade sections. Additionally, there's a one-for-one digital representation that is built of this exact same model, which is a digital twin of this smaller 3D printed jet engine turbine. We're able to leverage prognostics, scroll out 1 to 2 years out into the future to understand what this turbine would be experiencing if we continued to run at this specific duty cycle. We can then break down this larger engine into very specific components, all of which make up this very complex model, and understand root causes of specific failure points that we might be able to determine 1 to 2 years out. We can then use that information of this knowledge model to teach people how to go in and service large assets like this turbine. And so this can be applied to many other large industrial assets. Anything that has a surplus of sensors, information coming off of it, we can introduce this new way of how these things are going to react downstream and better prepare for servicing them in the future.
Yeah, hope you could able to see the video on the digital twin. So how it can be used. So and later part of the demonstration, we will show how to build as well using a tool called Creo. And so now we get into the first topic for today's session. So Industry 4.0. So industry, the transformation happened, started with the mechanization. It is more than a century ago. So people started steam for various industrial activities. One is the mass production of various components, people, and then people started consuming more number of products, and then how to manufacture at a larger scale. So that's where the mechanization happened. So that is the industry 1.0. And then the second major revolution happened after electrification. So this is during the time where the mass production of automobile manufacturing happened. So the typical example was Henry Ford's manufacturing assembly units. So where the electrification made a huge difference, making number of cars at per day, starting from few to hundreds of or thousands of cars. So that was the main transformation that happened. And then the third is the automation. So where industrial automation using the industrial robots, and then how to minimize or improve the productivity of people as well as the large equipments. And the last one, the industry 4.0, is what they call cyber physical system, because not only the individual machines can communicate with each other, and then people can also work in tandem with machineries or the robots. So these are the key revolution or evolution happen in the industry. So the first is what are the key aspects, right? One is cyber physical systems, and then connectivity is more, it is pervasive, and then the data, it is generating large quantity of data, beta zettabytes of data, it is getting generated, and then how to use advanced analytics on top of it, and then how we can build smart applications and services on top of it. So over a period of time, the timeline required for that changes within the industry has shortened. So earlier we used to spend years, upgrading certain systems, parts, or the hardware, or it is in IT related applications, or even it is the industrial embedded systems. But now it has to happen, matter of days or matter of hours. It should happen, and some of the transformation happened even on every minute. If you see the market providers like Amazon and other similar providers, every minute they update their code. Every minute there are 2,000, 3,000 changes to the code being made, and then without impacting the end users. So that is the highest level of changes happening in the hardware as well as software side, IT system side. And then the other aspect is how the transformation happened, right? So one is on the instrumented system. So where the initially it was more of a ability to measure and then sense and then act upon it and then trigger some physical activity on top of it. So that's what we call instrumented systems. So there's more of a visibility, right? What's happening in the manufacturing or the shop floor. Next come the integrated, because next, once the manufacturing process matured and then the data is enough, and then they next thought about integrating with various aspects, right? So one is you have the enough data about what's happening in the plant or the process unit, and the next is how to interconnect and then monitor their performance with respect to certain key performance indicator. So that's where the integration started. So it will enable the transparency at the end of the day, right? So you need not depend on any of the people, or more of a process driven approach can be incorporated in the industrial world. And third is the predictability, right? The current use case which we are seeing on the aviation turbine engine. So predictive maintenance is one of the key aspects, because these equipments are quite critical for the operation, as well as any interruption or the downtime of that particular critical equipment, it will impact their profit margin. So that's why they want to know when there is a performance getting lowered, and then what remedy or action need to be taken. So the predictability, it is one of the key factors of any industrial equipment. So all of this Internet of Things, which is going to enable, already enabling, and then going to enable further the predictable part of it. And last but not is the intelligence, how to incorporate the intelligence, right? So now the Internet of Things enabling us to not only sense, connect with the machineries at the shop floor, and also we can create some simple automate some of the actions, and then a few simple decision making rules or rules based some of the decision making can be incorporated in the embedded system itself. So that is the main aspect of edge computing, which is part of the or the extended part of the Internet of Things. I'll just play a small video on the industry 4.0, the transformation. So
the fourth industrial revolution has begun, and you have the chance to be part of it. This isn't going to be like before. It's not about the steam that powered our factories in the first revolution, or the mass production model that dominated the second, or even the emergence of computer-driven systems from the third revolution that we're living in today. Industry 4.0 is about connectivity. It's an opportunity to radically change the way industry responds to the needs of society. As previous industrial revolutions were led by innovations in manufacturing processes and systems, the advancement of Industry 4.0 will be driven by a smart, interconnected, pervasive environment. The opportunities for disruption are huge, and those left behind will feel it acutely. There is still space for leaders of this new revolution to emerge, but the race has already started. Understanding what current leaders are doing will help you join them. KPMG formally examined what those trailblazers were doing in their factories and their offices, and it revealed some thought-provoking findings. Our research highlighted a number of areas that current Industry 4.0 leaders are focusing on. Leaders are planning ahead with clear strategic vision, driven by performance and tying investment to proven opportunities for growth, progress, and innovation. They are focused on discovering how smart products and processes can be developed. Integration is key. The major players are moving away from isolated silo-driven development, which limits scope and value of new projects. Instead, they are moving towards large-scale and proactive integration across their enterprise and among their customers, supply base, and products. To ensure they are aware of every possible opportunity Industry 4.0 technology has to offer.
so that is how the current industry is focusing on Industry 4.0 and then how to leverage that. And this is on the Y part of again Industry 4.0. So this is one of the survey conducted as an organization along with the University of Aachen based in Germany. So we contacted hundreds of manufacturing companies, and then what Industry 4.0 impact, and then we created a maturity model based on this survey. So based on the survey, so two key aspects we came to know. So one is 85% of the companies are aware of potential for Industry 4.0 implementation under the benefits. And second thing is more than around 50% of the companies, the manufacturing companies, they want to go with systematic approach of implementing the Industry 4.0, and then which is invariably based on Internet of Things based approach. And then the key opportunities or how to implement, and then the systematic approach based on systems and then process driven approach. So that will going to improve the industry in the coming years. So, and in terms of the maturity model, so till the Industry 3.0, so it's more of enabling the enablement of IT or data enablement of the physical systems. And then the Industry 4.0 started with the four pillars, right? The visibility, transparency, and predictability, and then the adaptability. So So if you see the near term, so we got Internet of Things, which will enable us to get the more visibility on the plant operations, and then transparency in terms of integrating with multiple systems, whether it is what we call the enterprise resource planning kind of at a high level, and then the lowest level it is going to touch upon the sensor and the controller level, or probably some of the real-time data kind of storage environment. And then the predictive, so this predictability part and the adaptability part, it will be more involving developing an algorithm and mathematical equations around that particular equipment or a set of equipments, and to overall process optimizing the process to achieve the key performance indicator, and then profitability and then margin improvements. And then the adaptability is more on the self optimization. So the third pillar is more on the predictive. It's based on human centric approach. The final or the end goal of industry 4.0 is how we can use artificial intelligence and machine learning based models to self optimize individual equipments or set of equipments, so that the industry as a whole can improve their performance and create more value for their shareholders. Yeah. So some of the key industry for use cases, so how the industry can benefit implementing the industry 4.0, right? So one is factory visibility, so which we discussed earlier, and then the second is predictive maintenance because of the critical aspect of the assets, and then the duration of the fixation of the asset to back to production, and then the overall the equipment effectiveness. That is a key performance indicator for any of the equipments, which will be monitored on an hourly basis for all the critical assets of an industry. And then the digital factory, so all the models based on the physical activity as well as physical models can be built on the different framework to enable the end-to-end visibility of the what's happening in the factory. And then the fourth aspect is augmented reality, so which is what we are going to see in the second half of that. So how the augmented reality can help, since we have now Internet of Things enabled in most of the companies, most of the industries in the manufacturing plant. So how we can utilize the IoT data around each of the equipments, and then overlay the data on top of the equipments or the virtual equipment, so that it will help. One is the basic level, it should help in the product development aspect, new product development. And second thing is on the troubleshooting aspect, whether that particular person or the subject matter expert is near to the manufacturing or shop floor, or he is away from the full shop floor. So AR based approach can help them to analyze and troubleshoot that particular and then fixing the issues. And then last not but the least is the training aspect, right? So whenever new joinees get into the new industrial environment, so they need required level of training. So this augmented reality helps a lot, because some of the activities or some of the equipments more critical, and then we can't do any what if kind of simulation around those units. So that can be overcome by using augmented reality kind of approach. And then the fifth main use case is connected supply chain. So whatever the manufacture in the industry, from the raw material to product, so that has to be sent, or the logistically it has to be optimized to send to a particular, either it is a procurement of raw material or manufacturing, or dispatching the whatever the goods manufactured in the particular industry to multiple warehouses, and from warehouses to end customer. So this all has to happen in sync. And if you see, especially the key market players like Amazon and Flipkart and others, you can see how their supply chain made a huge difference in everybody's life. They use a lot of process has been automated. Even inside the warehouses, if you see, there are custom designed robots which carries various products and then rack them and then stack them and then monitor the inventory and then arrange for the dispatch. So everything it is possible because of the Internet of Things enablement. Because it is humanly it is nearly tough task to even simple stocking the things as well as distributing the things to multiple end users, at least in thousands of end users. And then the remote monitoring. So again, some of the critical assets are especially on the energy industry. Even today, if you see the unconventional or non-conventional energy resources like solar and wind farm, so the actual power generation equipments all scattered or installed either remote places. So that has to be monitored, and then even it is needs a lot of fine tuning to improve their performance. For example, if you take a case of windmills, which is located in southernmost part of India, but it needs to be in particular wind direction, right? It has to take the maximum efficiency. So they call the yawn angle. So the yawn angle has to be monitored, and then it has to be positioned in such a way that it creates maximum power. So those things all possible with the advent of IoT development. So, and then energy efficiency in all the aspects we need to take care. So, and then the integrated digital engineering. So where end to end. So here what we call the integrated digital engineering, nothing but product life cycle management. So maybe when you get into industry, you will come across these terms. And PLM, it's a main like from starting from conceptual design. So whenever you develop a new product, so it has to start with a clear-cut design based on the research and development activities, and then the end-to-end development is all what we call integrated digital engineering. So where you can see the 3D visualization of a particular product or particular manufacturing plant before even it is being constructed, and then you can walk through in those plants and then identify any anomalies or exception, or there is a overlap between two equipments or any pipelines or any columns or pillars is interrupting each other. So those things you can avoid the costly mistakes after post construction and then redoing such work. So those things can be avoided with the advent of the industry 4.0 and then the IoT based enablement. Even the real estate industry also to a certain extent they all use for the industry 4.0 or the IoT based scenarios. In terms of efficiency, the following the underlying text it shows. So we start with the engineering efficiency in terms of design, particular product, and then how to improve the operations of, and then improving the maintenance, and then the energy overall as a plant, as a company, as well as information efficiency, how efficiently communication happens. And then not least because now it is more of a service oriented economy as a whole. So not only we need to sell a product and then forget it, but we need to have excellent service, customer service or support level has to be at the highest to sustain a particular product or industry in the current scenario. So because the service level expectations it's set at a high level. So if you see some of the new products are like iPhone, so the even including the packaging, it has to be at certain level what of customer expectation. So it should not involve any additional instruction. Without instructions you can't share any of the services or improve the service levels. So these are all the key aspects of industry 4.0, and then we'll get into the industry 4.0. So now we get into a digital twin. So digital twin. So see, these are some of the reports from the key market trend analysis team like IDC and Gartner surveys. So one is digital twin going to remove the silos of inefficiency because we have more visibility on the what is the process as well as the hardware around that and the physical equipments around that. So and then creating models around that. And then by 2021, half of the large companies already they are implementing digital twin in some form, either it is in the product design part or the operations or at the service level improvement. So they are expecting about at least a 10% improvement in the overall equipment effectiveness. So that is translate into huge number overall that the top line growth for any organization. And then 30% of the global 2000 companies will be using the data from IoT, and then check the products and then enhance their product levels and then the asset level improvements, and then overall gain they are predicting around 25% of that. And digital twins in the context of IoT projects is particularly, it's next at least 5 years, it's going to transform the industry as a whole. And then that's the reason we have to, just put a little bit of effort and then understand how we can learn and then ready ourselves for the next revolution around that digital twin. And other key aspects. So the digital twin, the term coined by Michael Greaves. So he's a professor at Florida Institute of Technology. So when he says what are the key use cases which can be built upon the digital twin, right? So he mentioned 3 C's. So one is conceptualization, and the second is comparison, and third is collaboration, right? So what he means conceptualization is the way I conceptualize certain product or certain service, right? It could be very different from what other person think, even other colleagues what they think. So digital twin gives a place where we can exchange certain things at the conceptual stage itself, so that we all in the same page when we do a new product development. So that is a huge value add for any new development or innovation activities. And second is the comparison, right? So till I complete certain things, the physical products, I will not know, especially situation like engineering to order kind of situation. If you see like a building a large bridge or large equipment machinery, so which we cannot visualize unless we have certain tools and other aspects of data. So the comparisons keep uh, differentiator for, provided by the digital twin, so that we can visualize and see so what that equipment would look like after construction. So that is a huge differentiation. So from the virtual system to physical system, it will give a place to connect and then apply more thought process in terms of design. And third is a collaboration. So this is from the once you design and then implemented that particular equipment or an asset. So when you do operating that, so you have to troubleshoot them, right? So the for troubleshooting purpose, you may need to involve one or more people. So the moment you involve multiple peoples, then to explain them without a proper platform to exchange, right? So just to show them what's happening in the real site or the remote sites. So the digital twin give you a lot of yeah, important place in terms of hosting the particular equipment and then giving visualization and then giving a augmented reality based approach, so that the experts sitting elsewhere can understand the problem on the ground and just see the physical systems in real time, and then you can help the person on the ground to fix that particular issue, which will it is not possible without digital twin kind of platform. So these are the three key aspects, the digital twin. And then the other thing is training aspect, so knowledge capturing, what if kind of thing. And digital twin not only for physical operation or predicting the maintenance of any particular equipment, it also helps in terms of training people, because some of the workforce which especially in the energy industry, so they are all really aged people, so they are going to retire soon. So capturing the not only the documented knowledge, so even capturing the tactical knowledge around that, right? So each person he'll have his own way of handling things and the way of operating, the way he understands the problems and then way he resolves it differ from person to person. So digital twin will give a very good platform for standardizing those, capturing the tactical knowledge or the tacit knowledge which is gained by the aged workforce, and then of course overall optimization, and then the end-to-end supply chain process. So even with the today's context, we can monitor the various supply positions, or for example, if you take the large equipments and even aircraft movements and other things, so which will all helps in overall supply chain of the key industries, whether it is fast moving consumer goods or the market players who involves in the e-com business, or even energy industry, which typically use large what we call very large crude carriers, kind of large ships, which takes days or weeks to transport oil products from one country to another. So they all need digital twin kind of platform to monitor, and then uh, the change in expected time of arrival makes a lot of difference in the process industry, like a continuous process industry. So which are all possible only with the help of digital twin kind of platform. So some of the definitions of digital twin. So we seen what the person who coined the term, Michael Greaves, explained, and then so this is basically the representation of the physical systems in such a way that it helps in improving the process, and then organization performance, and then individual at the person level, as well as the data level. So this is the definition given by one of the Gartners. So coming to the applications of digital twin. So let me, I'm just connecting to demo system. So just give me a couple of minutes.
Anything to be installed, sir? Should they install something and get ready?
No, this is, I'm just going to show the browser only. So yeah, so hope you able to see my browser. So
Yes, it's clear.
yeah, so this is the one built on platform called PTC ThingWorks. So this is part of our what we call, we set up the IoT based demonstration for our customers, large oil and gas customers. So this is built on a platform called PTC ThingWorks. If any of you interested, so you can download the application. There is a trial version, 1 month trial version is there. So you can build, and this is a paid platform, but there's a demonstration version available for 1 month demo. So you can access from the web, and then you can use it. So just to show how the real life use cases, how we build. So hope you are able to see my screen. So
Yes, yes.
yeah, So this is one of the simplest use case in the industry. So they typically there will be large storage tanks in the industrial space, so which will store various raw material as well as refined products. So raw material is it's for like crude and other crude oil and other similar raw materials, and then the product whatever we use petrol, diesel, and other similar products. Most of them, fuel. So this is kind of once you have the Internet of Things enabled data in place. So the challenge is these are the terminals, what we call the group of storage tanks. It will be located, situated somewhere near the sea, and then they will transport. They'll receive the raw material from in the ship from Middle East or other countries, and then store it, and then they'll further process in the petroleum refineries, and then they manufacture or the refined products like petrol and diesel. So the monitoring of these remote storage tanks is generally a challenge because the operations team will be sitting elsewhere, and then they need to monitor these tanks because some of the tanks are huge in size, right? You can imagine like a 70 meters diameter tanks. So that is the size of these tanks in terms of physical size. So we can use the Internet of Things based approach to monitor the level, and then what's happening, and then we can remotely switch on and off the pumps, and then we can enable these changes remotely. So this is built on a platform called PTC ThingWorks. So there are similar platforms available with from other vendors as well. So this is to show how it will look like when you develop the visualization based on Internet of Things platform, and how it will help in the industrial scenario, right? So, and with the today's tools and other platforms, so it will not take much time. So once you learn the basics of the business knowledge, a business part of it, and then building on these tools will be really kind of very simple in nature. So just to show that how quickly you can develop the use cases in the Internet of Things platform. And then these are the couple of other visualizations. So like other characteristics of the particular storage tank. So how much is the incoming fluid, and then how much is the outflow, and what are the key temperature and pressure. So because these are the hydrocarbon nature, so we need to monitor the temperature, pressure all the time. So any variation beyond the prescribed level has to be given an alert. So which are all part of the basic functionalities provided in the Internet of Things platform itself. And this is one more visualization. So just to show the key rotating equipments, what we call the pumps, and their functions, and then what is the temperature and pressure again, what are the, if any anomaly in the pump operations. So those things can be monitored. So any variation in any of these parameters, so those all can be monitored, and then give provided an alert either to a mobile or to the their email. So most of them give an alert in the form of messages, short messages, or in the mobile, and then it give, and even way of creating the voice based alert also part of this Internet of Things platform. So, and whatever we see, the visualization can be ported to mobile as well as without any further uh, any additional development work. So whatever you see, you will get the same in the mobile environment as well. So these are the improvements in today's IoT platforms. And then apart from connectivity and visualization, and even the third part is the analytics as well. So some of the Internet of Things based platforms, they all provide even the analytics part of it as well. So even the PTC in ThingWorks has the analytics part of it. Probably we will see on the Friday session I will demonstrate similar to PTC. There is one more platform called Cumulosity from company called Software AG. So there we can see that platform as well. So how similar use case can be developed very quickly, and then we can demonstrate to the industrial customers. Let me check. No, my colleague has joined, Jeevan.
Okay.
Yeah.
I've shared the meeting link with him. We just have to ensure he has joined the meeting.
Yeah, sure. Just give me a minute. I'll just.
Sure. Okay.
Yeah, I think he has already joined. So can you unmute, Preeta?
Yes.
Yeah.
Has he joined?
Yeah, he has joined. Jeevan.
Okay. We welcome Mr. Jeevan. Thanks for joining us in this workshop. Is he there,
Yeah,
Jeevan? Yeah.
we could not able to. Yeah, is there. So you need to unmute, I think. Yeah.
Oh, 1 minute. Let me
Yeah.
check. Can you ask him to check now?
Yeah. Can you guys hear me?
Yeah, Jeevan.
Yeah. Welcome, Mr. Jeevan. Yeah. Thanks for joining us in the workshop today.
Yeah, thanks. Good morning, all. Thanks for having me.
Yeah.
Yeah, so I've been listening what Pandi was saying from the past 10 minutes.
Yeah, Jeevan. Yeah. So just a bit little short introduction about Jeevan. So Jeevan is again is a colleague of me, and then he has vast experience in the engineering, procurement, construction, EPC kind of industry, and he is a chemical engineer by profession, and then he has more than 10-15 years of experience in this space, and then his expertise is on the engineering design and then development and construction of large industries like oil and gas and power industries. And he is going to help us to understand the digital twin, and then how we can use AR based platform to understand further. So Jeevan, over to you. So just you share the details what mobile app they need to install.
Sure.
Yeah,
I'll do
please.
that. Yeah, so there is this particular app called Wooforia. Let me keep it on the chat window. The spelling of the app, it is, one second. Can you guys see the message I texted to everyone? So it's basically an app called Wooforia View, which is available on both App Store on iOS platform, even on Play Store for Android. It's a small software only. You can get it installed because to have like this augmented reality experience, like we need to have this Wooforia View on your mobiles.
Are you sharing any screen, Mr. Jeevan? We aren't able to see anything.
Yeah. I mean, I didn't share any screen. I just sent a message on chat window.
Yes, we saw the name. Yes. Okay.
Yeah. So once you are done with the installation part, like I can share you my screen. All you guys just confirm like when you are done with the installation part. Okay. Meanwhile, I'll be explaining the complete scenario.
Okay. So we request the participants to do the installation in parallel while he starts with the demonstration. Thank you. Yes, over to you, Mr. Jeevan. You can explain so people will install by then.
Yeah, thank you. So guys, just let me know if you guys can see my screen.
Yes, it's clear. Yeah.
Yes, Jeevan. Yeah, we could able to.
Yeah. Thanks. So basically, this is a CAD model. Okay, so we have designed this complete CAD. CAD is again like computer-aided design. So we have designed this complete unit on a CAD platform like PDMS, SP3D, or Everything 3D. There are n number of platforms available in the market. So basically, depending on our requirement, like we have modeled this complete unit. It's basically a as Pandey was explaining, it's basically a simple and precise cozy unit of a simple remote tank monitoring system. Guys, can you hear me?
Yes,
Yeah,
yes, yes.
Yeah. So on the left, you can see, let me zoom it there. So here you can see this particular blue color tank, right? So it is basically a small tank, which is basically the source tank. So from basically from this blue tank, the material or the liquid which is there in this particular blue tank is going to pumped with this particular pump. This is called the main pump. You guys can see, right?
Yes, yes.
Yeah, so this is the main pump which I'm highlighting it here. So through this pump, like we are going to pump all the way through this blue color line all the way till this gray color line. You can see, right? This is the gray color tank. This is the main tank. This we call it as the storage tank. Okay, so here, as you can see, once it gets filled, okay, so here there is this particular, you can see here, the one which I'm zooming in, these are the level indicators. Here you can see, right, this particular thing, this is a level indicator here for this particular tank. And there is one more here for this particular tank also, there is one more level indicator here. So this we have developed a simple use case scenario where a source tank is supplying particular material to the actual storage tank, which is the gray color tank. Okay, can you guys see that, right?
Yeah.
So generally what happens is, like as Pandey was saying, like, there will be the source tank, which is exactly on the seashore, because the seashore, these storage tanks, basically they get screwed from these container ships, because container ships, they can't come close to the shores. They'll be parked, or like, they will be moored, we can call, like they'll be moored at a certain distance from the seashore, and there'll be a pipeline running from that container ship to these terminal tanks. So from that terminal tank, like, we need to get the crude or a refined petroleum, that material to be pumped to the other tank which is in the refinery or in a certain place. Let's say, so we have compacted that in such a way that there is a source tank in blue color and there is a gray color tank which is a storage tank. So here we kept it side by side. Generally it happens like the blue color tank will be somewhere close to seashore and this gray color tank will be somewhere in the refinery. Okay. So we have kept it in such a way that we are pumping a material from the blue color tank to our storage tank, which is in gray color. Okay, so you can see there is a flow meter attached to this line. Can you guys see this? So this is a flow meter, because we want to monitor like how much is the flow rate, like how much flow rate the liquid is getting pumped. Okay, and you can see here on top of the tank there are two sensors. You guys can see, right? So this is a pressure sensor and a temperature sensor, because as Pandey was quoting earlier, like, because these are very flammable in nature, so we should be we should have a continuous monitoring on the pressure and the temperature of the materials. Okay. So here, once this liquid is pumped to this particular bigger tank, which is in gray color, okay. So again, it has got its own level indicator, and it's got its own temperature indicator, and it's got its own pressure temperature. Through these are basically the measuring devices, and continuously the data from these devices are keep sending this data on very frequent basis, depending on how much frequency we kept it, like depending on seconds, minutes, hours, we keep getting this continuous data regarding the temperature, pressure, and the level of this particular tank, okay, to our interfaces. So here the line which is in the yellow color to this particular tank, it's basically a recycle line. So here for this use case scenario, we kept it a recycle tank. Again, it's going back to the source tank. This is just for the use case scenario. Well, let me show the behind. So there is a yellow color line you guys can see, right? There is a yellow color line which is connected from this particular tank to again the blue color tank. It is basically an overflow tank. The same scenario we use for our overhead tanks on our, I mean, like, in our houses we use the same overflow tank, right? Once the tank gets filled, like, there'll be overflow line which keeps emptying the tank. So the tank won't get pressurized. So once you just confirm me, like, once you guys are ready with your applications installed on your mobiles.
Have you all installed? Please confirm on the chat window. Can we get it started with the demo?
So Jeevan, I think you can share the thing mark so that whoever installed, they can view the
Yes.
3D model in the AR model in their mobiles.
Yes. So this is the thing mark we were speaking.
So you can just focus your mobile app. That's like a QR code kind of scanner. So the code scanner, you can just focus on the thing mark or the code Jeevan is sharing. So you can visualize the model, what that 3D model, what we shown. You can see in your mobile app in the AR based, right? It will on your laptop or desktop. So it will kind of overlaid on top of it, the models.
Those who have installed the app can just check.
Yeah. So basically the 3D model, it'll you can see kind of live, and then you can just move your mobile, and then you can see the different views of the same that model. You can just kind of walk around that model. So
If anyone has any difficulty in having that experience, please do let me know.
Those who have installed the app can just try and confirm on it. Any questions, please raise. You can see on the chat window, one Mr. Nagarajan has installed. Have you tried?
So it is asking for a QR code.
yeah, the QR code you have to scan what Jeevan is shared, ma'am.
Okay.
On the screen, you can see the code.
The
Right?
scan, yeah, that's on the screen. There is a code, so that is the code actually. So you can just focus that scanner on the code, so you will see the 3D model,
Okay.
AR model of the scene. Yeah.
We are just checking on it. Anyone who has who's through with it? Couple of
Just
you
you
who
need
are,
to, yeah,
yeah.
just you need to just focus the scanner into.
Even we seem to have some issues scanning the QR code. Someone is saying the same thing on the
The
chat.
Vuforia view itself, the mobile app itself, there is a view, so there is a scanner. So
as soon as they install the app, once they click on that, like, they'll be getting a square box, how they get it for any kind of these paying apps also. You just need to scan that QR code, which is on my screen.
Sir, actually, I installed in my laptop. So,
okay, then mobile it will be easy, man. Yeah, you got it.
Others who have installed on mobile, do you still face a problem in scanning the QR code?
So you can see the same 3D model which G1 was showing. So it is in the AR environment, it will come. So
Yeah, there's someone who has confirmed that he could see the 3D model.
yeah.
Yeah, some RAM KB, I think,
Yes.
yeah, you can see it.
Rest of you, if it's on the laptop, you can quickly install on the mobile and try.
Yeah, mobile it will be easy to view that because laptop you cannot scan it. So
Pandi, the QR code is
yeah,
clear only, right, on the screen?
yeah. Maybe you can zoom it a bit. So
Let me try.
yeah, should not make a difference, but
Sir,
Someone is asking for the QR code. You have to
yeah, you can take a snap
take
of
it from the screen. Yeah. Like how the regular QR code scanner works, you should be able to
Yes.
scan this using your mobile app.
Yeah, there's
And
a
you can
scanner
try
in
that.
the Vuforia itself. Yeah, please use that. Yeah.
So Jeevan, can you please zoom it? Will that help?
Yeah, I'm doing that. 1 second.
Thanks.
So is that fine now? Now I kept a Zoom version.
Yes. Couple of them
Excuse me, sir.
have completed. Yeah.
Can we do it only in this CAD software, or more? Is there anything like that, sir? Like, one minute. If we are doing the same or some model in some other CAD software, and can we view that same in like this using this same viewer?
You see, the thing is, that's what I'm saying, right? We have developed the CAD model in other platforms, in other CAD designing software platforms, and we imported that onto Vuforia Studio, which is again a PTC software. So there we need to add the complete model. We need to import the CAD from whatever platform or other softwares, like we have model.
AutoCAD.
Yeah, correct. AutoCAD 3D, you can do that. Actually, the model which you are seeing right now, it is made on AutoCAD 3D only.
Yes, sir.
Yeah,
So
so
that we should save that file and we should import it to this.
Correct.
And we
Correct.
can.
Correct. Once we import it, and we need to add certain experiences, and then we made it, feasible for the augmented reality through this software.
Okay, sir. So then this Euphoria, this thing is like we should pay for it, or it's a demo model or something, sir?
That's what it is. Actually, it's a paid platform. I think you should be getting a 30-day free trial version, and after that, maybe you have to get it paid.
Yeah, you can download for 1 month 30-day trial, so you can explore this tool. And
yes.
then for AutoCAD, you can use the free CAD tools, and you can develop. But the main this thing is key point is you need to create of it. So if I say pump, then you have to create the model for all those components. So then only it will give good experience. What we call the experience view. So
Correct.
you able to disassemble the things, right? If we have 10 different sub assemblies, so you should be able to split and then see that. So you have to go to the nut and bolts level. So all
Correct.
those has to be incorporated in the CAD models. So then it will give a very very good experience or perfect experience with this tool.
So basically, with this tool, it's basically like we give the management or the leadership like to take some effective decisions much before it was erected, or much before they're actually shelling out their pennies out of their pockets. So it's basically to build some kind of confidence to the leadership team. At the same time, like if there is any kind of anomalies which were actually we found on the ground team, like we can send our ground maintenance team to see how exactly they need to fix that issue through an augmented reality experience we can add. As Pandey was mentioning, we can go to the nut and bolt to that minute detailing also we can do in this particular software. So the actual ground staff can see how exactly they need to disassemble one particular part, and what is the operations you need to follow in successfully fixing that issue for a safe operation.
And the main important thing is building such AR-based model is you need to have the sequence of operations. So how you do any simple task of removing or fixing the particular part of the machinery. So you should know what are the 10 steps, right? I need to unscrew the bolt, and then I need to remove the first casing first. And so all the sequences, if you know, and so once you have the models and then the sequence, that's all. Once you have these two like a script, then you can execute. This is like an animation tool, right? So you can execute the sequence in steps. Like
correct. So basically, the current practice which is going around in the actual world is they have the standard operating procedure, which is a hard copy, which is given to these maintenance guys. So they go and perform each and every task, and they keep ticking for each and every task they have completed. In that way, they're performing the task these days. But this particular software, will give them the complete animation video, what all steps to do and how it should be done. Each step, how it should be done, they give a complete. They can see the video in front of their eyes, how to get it fixed, how it is removed, how it should be removed, and which side to turn the bolt. To that minute details also, we can include into this model, so that the maintenance guy should not be finding any kind of difficulty in fixing the issue. And most importantly, it gives such a competitive edge for the business perspective also. Like, we are giving a lot of confidence to the client that sitting somewhere on the other corner of the world, he can easily monitor and who can see what's exactly happening the other side of the world. So that gives a complete edge on our competitors also from the business perspective.
There is one participant who has confirmed. Okay.
So you can download yourself the trial version of this tool. So PTC ThingWorks, and then the Creo tools. So you can try out yourself. Maybe you can take a simple, small physical model of version, and you can create. Probably the FreeCAD tools are there. FreeCAD drawing tools. So you can use FreeCAD and then create a model, and then you can visualize to understand how this the augmented reality, how it works.
So done?
Yes, I
Yeah,
think
Jeevan.
most of them have. They are seeing it to work now. Most of them have confirmed. Thank you.
Okay. So someone is saying we can simply zoom it. Let me tell you one thing here. The thing was what we are going to do, we are supposed to give how much is the ratio we can show. Okay, it's not like simply we can't just zoom it. The thing is, depending on their size ratio, how much the actual unit they can see on the phone, it should be actually matching to the ratio or the size of the QR code which we are placing here on the design model. If you are keeping it, if you are keeping the QR model big and if the unit is small, they can see some tiny particle on their mobile. So we have to see the ratio. How much the scaling thing is one big thing. Let me show you if that is possibility.
So in real world, these QR codes, it's like a barcode. So they will take a printout and then they will paste it on the equipments.
Correct. So here, the scaling, the ratio of how much big the QR code, it should actually fit the scenario here. So that is why, I can show you. You can see there are 3 codes of the same size. You can see that, right? There are 3 codes, so of the same size. So it is basically how much I decide, how much my things work ratio, and it is matching with my model or not. That's the issue. Okay.
So any queries, and we can take upon. So, and then for the tomorrow session, we will be discussing about the protocols, the MQTT protocol, and then the OPC unified automation or unified platform. So, and then there are few browser-based demo simulators we have shared, so you can use that for tomorrow's session. So.
So Pandi, you want me to
Yeah,
stop
yeah.
this sharing?
Yeah, you can.
Yeah.
Thank you, Jeevan. Yeah, for your
Yeah.
time.
Thanks, one and all.
Yeah,
Thanks, Preeta.
thank you. Thanks to you.
Yeah.
Please raise your queries, any clarifications, any questions that you would like to get it addressed. If you have any questions, please raise. You like to discuss something or you want to clarify something, please raise. I think then we'll,
Yeah.
can we close? Any
Yeah.
questions? Okay. Okay, thank you very much, sir. It was a useful
Yeah.
session again today. Thank you so much.
Yeah.
So
Thank
we'll
you, everyone.
connect.
Have a good day.
Yeah,
Bye.
thank you, sir. Thank you. The feedback form link for today's session is shared. Request you all to fill it before you leave the call. Huh? Andisha? This feedback link is posted in the chat window. Please fill the feedback form before you leave the call.